So in this question here, we've got x squared plus y squared equals 4, and then we need to find a tangent line which touches this circle. And the point where the tangent line touches the circle has got these coordinates p, 1. P is greater than 0 at the point where y equals 1. That's what we're interested in. And we want to find the equation of that tangent line. So first of all, let's draw this circle. Now, as it says x squared plus y squared equals 4, that is a circle of radius square root of 4 centred at the origin. Square root of 4 is 2. So what we will have, if that's our coordinates, we'll have a circle like that, and that will have a radius of 2. And we'll call that the centre point, and it's got a radius of 2. So therefore this line here will be 2, this line here will be 2, this one 2, and this one 2, and so on. Now we've got a point p, 1 where a tangent line is formed. So p we don't know, all we know is that p is greater than 0. Now p is reference to our x coordinate. So this is our x coordinates, this is our y coordinates. The y value will be 1, that we can see. So we coordinate to there. And p, which is greater than 0. So that's going to be on this side. So it has to be in this quadrant. It can't be here, here or here by these values here. So if y is 1, it will come along here, touch the circle there. That'll be our p, 1. So that is p, 1. Now what we want to find out is where it comes down and touches our x-axis. That would give us the value of p. So how do we work out where that point is? Well, a good geometry question here. We can see it's a circle. This is our centre. This is a radius of 2. This is a radius of 2. So if you take this point here where the tangent line is formed, we also get another radius of 2. So now what we've got, we know this will come straight down here and make a right angle. So now we know that this length here is also 1 by the value of this coordinate here. So that one there is also 1. So now we need to find the length here all the way across, because this 2 just gives us our radius. That goes all the way across down to here. Now what's the length to here? Well, here we've got a right angled triangle. So let's take it out of the circle. Just draw it here. We've got side 1, hypotenuse of 2, a right angled here. What is this length here? That's going to give us p. Now, how do we find that? Well, as it's a right angled triangle, we can just go into Pythagoras' theorem. So Pythagoras' theorem, a squared equals b squared plus, in this case, p squared. So a squared is our hypotenuse, b would be here, and p would be here. So that can be our a, that can be our b, obviously that's our p. So a squared, that's 2 squared, equals b squared, which is 1 squared, plus p squared. And then we need to solve for p squared from here. So we've got 4 equals 1 plus p squared. So then if we subtract 1 from each side, 3 equals p squared. So p equals plus or minus square root of 3. Well, a length cannot be a minus value, so we only keep the plus value. So p equals square root of 3. So now we can change this value here to square root of 3. So let's just put that in there. Okay, now we need to find the equation of the tangent line. Now the tangent line will be like this along here, touching the circle, and it will form a right angle where it touches the circle. Now how can we find that equation? Well, first of all, we can find the gradient of this and then find the negative reciprocal of that gradient as it's a tangent line. So what's the gradient of that? Well, what we need is m equals change in y divided by change in x. So we can work out the gradient of that by changing y, which would be from 0 to 1. So the change in that is just 1. The change in x goes from 0 to square root of 3. So square root of 3. So that's our gradient of that line. Now we need this negative reciprocal for our tangent line. Now the negative reciprocal of that will be, let's put this over here, so we've got minus root 3 over 1. So flip it over and put a minus, which is minus root 3. Now that's the m value of our tangent line. So we've now got y equals mx plus c. We know what the m is, it's minus root 3. So y equals minus root 3x plus c. Now how can we solve for anything in there? Well, we've got this point here which we know is on our tangent line. So when y is 1, x is square root of 3. So let's put that in there. So y equals 1, x equals square root of 3. Okay, let's plug that into there. So then we will get, let's bring that up here, 1 equals minus root 3 times x, which is square root of 3, and then plus c. That's what we got there. Okay, minus root 3 times root 3 just gives us minus 3. So 1 equals minus 3 plus c. So now we can solve for c by adding 3 on both sides. So then we'll get c equals 4. So now our equation here, we can finish it off. Y equals minus root 3x plus 4. Now we need to try and get it into this kind of format. So now we want to bring this across to this side and leave the c value on its own. So we need y plus root 3x equals 4. So then our a value is 3 and our c value equals 4. And that completes our tangent line which touches this circle. Okay.